All right, so now that we have an understanding for what functions are, again, you cannot have any double y values, meaning you can't be in two places at once, just like, again, I keep referencing that turtle problem. When he split into two people, no longer a function. So we have three basic graphs here. So you should have thought about them a little bit and tried to figure out, are they functions? And then explain how we know. So if I look at this one, this is a graph that you're going to see a lot of once you move on to algebra 2. It's called a parabola. This is a function. If I go ahead and look, all of my x values, if I run my mouse down that graph, all of my x values only have one y value, right? If I look here, I'm not hitting the graph twice. So I'm going to say yes. Oh, my pen's off again. Eventually I'll get the hang of this. So yes, each output, or I'm sorry, nope, each input for your x, each input has exactly one output. And again, what is key here is to remember that when we're talking about functions, we're looking at double y values. Okay, so it's okay that I'm hitting, let's say this value 5, I don't know, I'm hitting 5 on the negative side and I'm hitting 5 on the positive side. What I want to make sure is that my x value doesn't come up and hit two values at the same time. Okay, I'm allowed to have double x values here. Like I'm saying, we're trying to make sure we're not having double y values. So yes, that is a function. Each input has exactly one output. If I'm looking over here, this is going to fail my function test, right? Because if I come over here and say, I don't know, I'm going to put some numbers in so that it's easier for me to talk. 2 seconds, let's talk about walking again. So if I'm at 2 seconds, I come up and I hit my graph here at, I don't know, 3 meters. And then I hit my graph here again at, I don't know, negative 3 meters. So whatever we think this graph might represent, I'm just making these numbers up. But at 2 seconds, I'm at 3 meters and negative 3 meters. It's impossible for us to be in two places at once. So we're not a function. We have each input has two outputs. Again, the language of x value, independent value, input domain, that's all the same thing. Output y value, dependent range, that is all the same thing. So to be a function, I have to make sure I'm not hitting two places at once. Over here, this is what I was referencing up in this problem where I was kind of doubling up. So if I'm looking at this graph, it really could mean anything. Let's keep going on with our walking example. So it seems here that at time 0, I'm kind of walking backwards. I'm going further to the left. And then over here, I'm going further to the right. So it begs the question, is this a function? So I see my graph here is good, right? I don't have any of my x values hitting more than one y value. Same thing for this portion of my graph. All of my x values hit only one y value. My issue comes from this middle part. So we're trying to think, what is happening here? So if I zoom in, is this x value of 0, we're not sure yet, is it hitting two places at once? Okay, I don't know why it zoomed in here. Okay, pay particular attention to your points here. This is filled in, this is open. That means that although I am on the y-axis twice here, my coordinate only belongs to 1. So since this is my filled in point, and again, I'm just going to make up my value. Let's say it's -2. My y value for 0 is assigned to the -2 because I have my open circle here. Okay, so I'm not assigned to both because one is open and one is closed. That kind of takes care of that situation that we were looking at before, where we're looking here, well, how can I be running at 11 and 15 miles per hour at the same time? If you're showing that instantaneous change or that instantaneous jump that might be happening at the same x value, we represent that in the graph by showing that one is closed and one is open. Okay, so whatever I'm walking, and then I have an instantaneous change in speed, if that's what we're talking about, or time, if that's what we're talking about. So it's no longer assigned here. Okay, so I am a function because no y values repeat. And again, we're paying attention to here to the types of points that are drawn. To show that instantaneous change in time or distance or speed, you may be located at what seems like the same spot on that y-axis, but I'm designating it by keeping one point open and one closed to show that I'm including -2 down or -2 down here. However, I'm not including my y value up here.